Okay, so now let's concentrate on ESD protection. So basically, electrostatic discharge is one of the most important cause for chip failures, not only in the manufacturing but also in the field operation. So this electrostatic basically can occur when the charges stored in the machine or a human body. What are the human charge stored in the human body are the machines that will be discharges to the chip on contacting other static induction by contact or by static induction. That is the main important thing in this case. So that means, so whenever the human body touches the circuit, so what happens? What are the charges stored in the human body that will be enter into the active circuit, and what are the charges there that will be completely destroy the circuit operation. So that means that is the that is called, because of the electrostatic discharge, that IC will be damaged. Okay, that means it cannot be works properly here. So that means why the human body how much voltage the human body will generate. Okay, so remember when the people walks, basically when the people walk, they generate some amount of electricity, and that electricity discharges to the ground. Okay, when the people walks through it will be anything on the synthetic carpet, and he is having 80% of in the environment we are having 80%, approximately 80% of humidity. Then the human body generate 1.5 kilovolts. Okay, 1.5 kilovolts. Otherwise, you can consider that for every step of the human body per second. Okay, so he can generate 300 volts. So therefore, when the human body walks to approximately 10 seconds, that means 10 steps. So what happens? Up to 3 kilovolts voltage will be generated by human body and will be stored in his body. And whenever he touches his finger on the circuit, so what happens? That charge will be discharges from the body and enter into the device under test, that means on the circuit. So whenever this amount of high amount of that's why it's called electrostatic discharge. Voltage signal will be transferred into the circuit. That circuit will be collapses. So that is that signal is we can call it as electrostatic discharge. Okay, not only the human body, but what are the machines you are having? That machines also generates more compared to the human body. They generate large amount of current. So okay, that's why we are having different methods in this case. So we are the capacity, that means whatever the concept, a charged human body can be modeled as so because of electrostatic discharge, the charged human body can be modeled as a capacitor having the value is 100 picofarad. Okay, 100 picofarad, and at the same time 1.5 kilo ohms discharging resistor. Okay, this is the human body. Okay, because the human body stores amount of energy, and that the energy discharges to the ground with the 1.5 kilo approximately. Okay, so therefore this is we can consider that the human body can be modeled as 100 picofarad and 1.5 kilo ohm discharge resistor. For example, assume that when the switch is here, so it means when the switch is here, that means the human body walks. Okay, the human walks. So what happened? It generates a more amount of power, okay, energy, this signal. So that means that signal will be charges this capacitor. Okay, that means the human, okay, charges. When the switch is here, so what happened? Whatever the charge is there, that will be entered into the circuit. That means that indicates here when the body touches the circuit. Okay, when the body touches the device under test, so what that means touches the circuit. So the whatever the signal is having, that signal will be transferred into the device, and the device will be collapses. Okay, within the very short time, because within the very short time, the signal will be enter into the active circuit and there will be collapses. Okay, so that is the main important of the electrostatic discharge that it can be generated in the man and also the machines. Okay, so we are having different models in order to analyze. So the different model for this electrostatic discharge testing. The first one is called the human body model. Okay, first one is known as human body model, and the second one is known as machine model, and the third one is known as charged device model. Okay, first one is the human body model. Okay, remember that point. Okay, in the human body model, the human can be modeled as 100 picofarad capacitor and 1.5 kilo ohm resistor. During testing, the capacitor will be fully charged by several kilovolts. For example, it may be 2 kilovolts, or maybe 4 kilovolts, or maybe 6 and 8 kilovolts. Okay, typically the electrostatic, the several kilovolts here. And then that charge can be discharges through this 1.5 kilo ohm resistor, which is connected in series with the device under test. Okay, that is called a human body model. Okay, so remember here. So that means here we are going to model a human body by using 100 picofarad and 1.5 discharge capacitor, discharge resistor. And this is the source of the signal, source of the circuit. That means we can model the circuit. That means we are going to model the human body by using a capacitor in the laboratory and with 1 mega ohm resistor and supply voltage. Okay, so therefore, when the switch is here, the capacitor charges. When the switch is connected here, it will be discharges like this. Okay, so that is called human body model. Okay, similarly, so therefore, that is the main important. And when the human body touches the just remember from the figure, you can say from this figure A, from this figure you can say that. So when a touch of the charged person's finger simulate by discharging the 100 picofarad capacitor to 1.5 kilo ohm resistor. Okay, so it is most important that some that means we require some protection circuit. Our protection network can be designed into IO circuits in order to protect the chip from the electrostatic discharge. So when for example, if you design a such circuit, the protection circuit in IO circuits, so what happens is that IO circuit, that protection circuit, filter the signal before filter the noise or electrostatic discharge signal before entering into the internal circuit. That means before propagating into the internal circuit. Okay, so that is the main important here. So that is the advantage of the protection circuit. Okay, in order to save the circuit, in order to protect the circuit, we require some protection network. Okay, and what is the protection network now in this case? Okay, just remember. So not only the human body, okay, we'll discuss afterwards. Not about the human body, not only the human body, but we are going to contact with the machines also. Okay, machines also. The machines also causes the electrostatic discharge stress. Okay, so that means, for example, this machine model is sometimes called as zero ohm machine. Okay, zero ohm model. Okay, so it is used to design. It is designed to simulate machine discharging to a device to the ground. Okay, discharging to the device to the ground. So in this test setup, a high voltage supply in series with the resistor charges a capacitor. Okay, in this test setup, so what we are doing, a high voltage supply in series with the resistor to charge a capacitor. For example, just observe here. Okay, to charge a capacitor. Here we are going to model the machine by 200 picofarad capacitor and zero resistance. Okay, we are going to consider a zero resistance here. Basically, we are using 0.5 microhenries inductor here. Okay, So that means the inductor moves like a short circuit for DC supply, because the capacitor charges like the charges. So it can be considered as a short circuit there. So 0 ohm resistor basically. So you can be model a machine is 200 picofarad and with a 0 ohm resistor, similar to the human body model. Okay, just the machine model is similar to the human body model, except that instead of using 100 picofarad, we are going to use a 200 picofarad, and we are not using this 1.5 kilo ohm resistor because it is a machine. Okay, so the machine not having any resistance, so there is a conductor. That means the current capability from this machine will be very, very high. So therefore, the circuit under test will be destroyed when this type of electrostatic discharge. Okay, so the capacitor device under test will be damages. Okay, that is the line. So we require some protection circuit in order to protect the device from the human body model and also from the machine model. Okay. Now similarly, the third one. Okay. Similarly, we are having a third one. The charge device model. So here the charge device model simulate the device damage that could not be simulated by a human body model. Okay, remember that means when the human body model will not able to simulate the device damage, so that can be modeled by using a charge device model. So here this charge device model simulate a device charge either directly, okay, directly by electric field, okay, electric effect, or indirectly by electrostatic induction, okay, by using electrostatic induction, remember. Okay, and this static charge stored in a parts body, okay, in a device machine's parts body, and that body discharges the depending upon the outside environment. Okay, that signal will be discharges the outside of the environment. Okay, so basically this test simulates the situations that happen in the manufacturing environment. Okay, this type of simulations test can be used, can simulate the situation that happens in the manufacturing environment, such as mechanical device handling. Okay, mechanical device handling that builds up charge. Okay, mechanical builds up charges when the when you consider the machine by handling the machine, so there is a chance of getting a electrostatic discharge. So that can be build up the electrostatic charge, and it can be discharges to the ground. Okay, that is when the ground touches the device under test. Okay, device under test by using a discharging probe. Okay, just observe here. This is the charge we are having. That means you are having a charging device. Okay, the charging the capacity, what are the device under test which charges here? Okay, by this charging model. So in this case, when the discharging probe is touches here, so suddenly what happens that whatever the data charge stored in this device will be discharges. Okay, so it not affect on this device. So there will be discharges. This is the discharging device that is outside the ground. That means it goes to the ground level, outside the environment. Okay, so like this we are having three type of models. So for ESD protection, one is called human body model, another is called machine model, another is called charge device model. Okay, so in the next class we can see what are the different models we are having. Just observe here the third model. Basically we are having consists of these are the models or different models we are having. Okay, so this is the assume that it will be a device model, HBD model, HBM model, or maybe MM, that is the machine model. We can test these models by using different circuits here. That is the lumped circuit element model. Okay, that is a simplified model. Instead of using a resistor directly charge the capacitor, we are going to charge the circuit by this method. This is the lumped circuit element model. Okay, So it may be suitable for not only for the hybrid model, human being model, but also for the machine model also. Okay, so there is also human based or human body model or machine model also. Okay, so therefore we need some protection circuit in order to protect the device from this the electrostatic discharges. So this electrostatic discharge network basically consists of diffusion resistors diode structure. Okay, here we are having a diode structures like this. Okay, so here the diodes are used to clamp the voltage to some level. Okay, to clamp the voltage so that the signal cannot be propagated into the actual die. Okay, so therefore we'll discuss these topics in the next class. Right. I'm going to stop the screen now.